A block of mass 3m can move without friction on a horizontal table. This block is attached to another block of mass m by a cord that passes over a frictionless pulley as shown below, or over here. If the masses of the cord and the pulley are negligible, what is the magnitude of the acceleration of the descending block? So first let's draw some diagrams, or free body diagrams. So here's the one for the block of mass 3m. You have the normal force and the gravity, the force of gravity, and these are balanced. And we can ignore these since there is no friction on the horizontal table. And then over here, pointing to the right, we have the force of tension because it's connected to the string. And then now for the block with mass m, again, we have its weight, mg. And then we have the force of tension that's pulling it up. And now we can just use these two diagrams. Now, one quick note, since g is positive, we're using the convention that the downward acceleration in downward direction is going to be positive here. So we're going to write mg minus the tension force T is equal to mass times acceleration. This is simply Newton's second law, which says that the net force is equal to the mass times the acceleration. And so this is the net force. Again, according to convention, G is positive since the downward direction is positive right here. And then for this one, we can just simply say that the tension force is equal to the mass of the block times the acceleration. And we know that the mass of the second block is simply 3m. So we get that the tension is equal to 3 times the mass times the acceleration. So now we can plug this back in over here. So we get that the mass times gravity minus 3 times the mass times the acceleration equals mass times acceleration. Now all of the masses cancel out. So you're left with this. So you get that 4 times the acceleration is equal to g. And now, so then we could simply get that a is equal to g over 4. And that is the magnitude of the acceleration of the descending block. This expression right here.